Okay, I'm going to go over a couple of different force diagrams and motion maps from a couple of scenarios here we can look at. This first one you see, there's a block or a box, and it's moving to the right, as it says, and it's slowing down. That's indicated by the fact that these motion lines are actually getting closer together as the box moves along. So because they're getting closer together, we assume then that means it's slowing down, and again the statement says also it's slowing down, so that's our information given. So let's first start with the motion map. And again, we start with the zero position and positive direction noted, and I'll just start it at the zero position, even though we don't really have a zero position indicated in our picture. And I'll start it with a large arrow for velocity, and those arrows should be getting smaller. And again, why is that? Because it's slowing down, and as it slows down, the velocity arrows that we use should be getting shorter as well. Now, the acceleration that we would put in here, we have to indicate what direction the acceleration is for this scenario. And because it's moving to the right but slowing down, the acceleration has to be in the opposite direction as the velocity. Again, it's slowing down, moving to the right, which means the acceleration is opposite direction of its velocity. Now, we have an acceleration then. It's slowing down. We have an acceleration. So now we have to answer the question, are these forces balanced or unbalanced? Well, if we do have an acceleration, then the forces have to be unbalanced. So as we draw our force diagram, we have to be mindful of the fact that this diagram has to show an unbalanced force. And of course, the force we have in the downward direction is gravity. Again, we are earth-dwelling creatures, and we cannot escape this force of gravity. Force of gravity on box, we'll call it. There's also a force upward on the box, and it is the same size as the gravity force, and we might call it force of, I don't know, maybe it's a table that the box is sitting on. So force of table on box. Now at this point, knowing that this has to be unbalanced because of our acceleration here, and knowing that the acceleration and the unbalanced force have to be in the same direction, that leaves us only one option, that the unbalanced force here in this diagram has to be to the left, in the same direction as our acceleration is. Now, what kind of force is it? Because I don't see anything in the picture. There's nothing on either side of the box that's pushing it. And so what could it possibly be that's acting on the box in a direction opposite of its motion? Well, there's only one kind of force that does that all the time, and it is a friction force. And that's the only one that makes any logical sense here, is that there is a friction force between the box and the surface that it's on, the table, that's causing it to slow down. It's a force that is opposing its motion. So we would call it the force of friction on box. And so then we see that we have unbalanced forces, and we also have an acceleration in the same direction as the unbalanced force. So everything in our diagram here matches. Let's look at another one quickly. So this one, we have a box on a surface here, and it has a constant velocity to the right, again indicated by equally spaced motion lines. And there is a tension force on a string here that's pulling on this box. So again, motion map, we start with our zero position in positive direction. And notice how I'm making these arrows. These arrows in the motion map should be all the same length. Why? Because it's traveling at a constant velocity. My acceleration would be zero, because again, it's constant velocity. Now, because its acceleration is 0, that tells us something about the force diagram. The force diagram has to be balanced. And so again, we're seeing the same two forces involved here. We have a force of gravity on box, and I'll abbreviate for time's sake. And we have a force of table, we'll call it, on box. Now, we clearly, based on the picture, have a force of string on box, and it's pulling to the right. So force of string on box. So far now, this force diagram is unbalanced. But because we have no acceleration, we know it has to be balanced. The only way to make this balanced is for there to be another force acting to the left. So the question becomes, what could it possibly be? We have nothing in the picture here indicating, other than the string itself, that there is some force in the horizontal plane. So we then have to use our deductive reasoning skills here to say that there must be some friction here acting between the box and the surface of the table, because that's the only logical way that there could be a force acting to the left, since there's nothing else in the picture that would indicate otherwise. So we will say force of friction on box. Now we see that we have balanced forces right and left, we have balanced forces up and down, and we have no acceleration, which is working for us. Here we have another scenario here. Now I have a pulley with a string over the pulley. I have a box being lifted, or a block being lifted up by the string as someone pulls it over here. We have motion lines that are evenly spaced, which again indicate that there is a constant velocity, and again it is upward, an upward constant velocity. So what does the motion map look like? Well, for these, I like to rotate the motion map so that it is vertical, so that it matches the picture. And right here is what that might look like. And again, the arrows are going up because that's the direction of the velocity. They are constant length because it is a constant velocity. And since it is constant velocity, we have no acceleration. And because we have no acceleration, we cannot have an unbalanced force in our diagram. Now, we have force of gravity, again, on the box, because it's always acting. We, in the picture here, show a string in contact with the box, not the pulley, not the pulley support, not the person over here, but the string itself is what is in contact with the box, and that is exerting a force in the upward direction. How much force? Well, since we have no acceleration, this force has to be the same amount as this force, but in the opposite direction. And so we would call it force of string on box, which would give us a balanced force diagram, which agrees with our statement of no acceleration in the motion map. So there you have it. There's a few examples of how these force diagrams and motion maps can be constructed, and how the acceleration will tell us whether the forces are balanced or unbalanced if we pay attention to the details given to us in the scenarios. So I hope this has helped a little bit.